Hello there. Today, take a moment to relax your body, breathe in deeply, and let your mind drift back hundreds of millions of years, when the earth was still blazing hot, when the sky carried the crimson glow of molten lava, and when the very first creatures called dinosaurs began to walk through the ancient mist. Have you ever wondered, what did dinosaurs really look like? How did they live? How did they breathe? And why did they vanish from this planet? Today, we will open the door of time together to explore 100 wondrous truths about the creatures that once ruled the earth for more than 160 million years. A journey not only about science, but also about life, death, and the eternal heartbeat of this planet. Fact 1. Dinosaurs were not just ordinary reptiles. Imagine, you are standing in the middle of a red land like Mars. The early sun casts a warm orange light over the dusty ground, and the wind carries the scent of hot stone, of time itself, of something so ancient it seems never to have had a name. This place, more than 230 million years before us, is the Triassic period, and beneath this soil, the world is preparing to welcome a new creature, the dinosaur. At that time, Earth was unlike anything you've ever known. There were no continents as we see today, only a single supercontinent called Pangaea, enormous and barren, endless deserts, dried up rivers, and volcanoes roaring from the cracks of a young planet's crust. In the sky, there were no birds, only clouds of ash and sometimes streaks of light, meteorites falling upon the scorching land. Life had just returned after the greatest mass extinction in history, the End Permian event, when more than 90% of species vanished. Earth was empty, cold, and lonely. Yet, in that silence, life began to recover. From small reptiles, frail amphibians, slow riverbank predators, and then, in what is now South America, a different creature emerged. It was not a snake, not a lizard. It stood upright, its body balanced on two hind legs, head raised high, tail stretched out behind to steady itself. Such a body plan had never existed before. It did not crawl, did not slither. It walked, ran, and observed. Scientists later named this group Archosauria, meaning ruling reptiles. From this group, two separate lineages would rise. One would become ancient crocodiles, the other would become dinosaurs, and much later, birds. What's fascinating is that archosaurs did not only differ in bones, but also held a hidden secret within, a circulatory and respiratory structure entirely unlike normal reptiles. Their hearts were divided into 4 chambers, like in birds and mammals, enabling highly efficient oxygen and energy transfer. That meant they could move faster, stronger, and for much longer. A spark of evolutionary momentum. In the Ixigualasto Valley of Argentina, where winds cut through the red stone, paleontologists discovered the first traces of primitive dinosaurs. Herrerasaurus, a predator standing about 3 meters tall, and Eoraptor, smaller, more agile, perhaps the earliest ancestor of all later dinosaurs. If you saw Eoraptor, you would be surprised. It did not look like the massive dinosaurs of imagination, but like a tiny bird with long legs, a straight tail, and sharp, alert eyes. Its bones were hollow and light, letting it move far quicker than any reptile of its time. This difference is the key. Ancient reptiles walked with sprawled limbs, bellies near the ground, like crocodiles today, but Eoraptor stood upright, like a human in motion. The way it walked changed the entire course of evolution, opening the age of movement, hunting, and dominance. One major advantage dinosaurs had was the way their legs attached to their bodies. Picture a crocodile's skeleton. Its legs jut out sideways, forcing it to crawl across the ground, wasting energy and limiting speed. But dinosaurs developed a vertical hip and leg structure. Their legs were placed directly beneath the body, a perfect design for weight bearing and endurance running. like the difference between a person crawling and a person walking upright. This gave dinosaurs two absolute advantages. They stood taller, seeing further, spotting prey or predators first. They moved faster and spent less energy, becoming the earliest rulers on land. From here, dinosaurs were no longer just reptiles. They were an independent evolutionary breakthrough, a radiant branch of life. For decades, scientists debated, were dinosaurs warm-blooded like birds and mammals, or cold-blooded like reptiles? The latest studies suggest they were somewhere in between. Dinosaur bones show growth rings, like tree rings, proving they grew rapidly and continuously. Unlike slow-growing reptiles, they had higher metabolisms, faster heartbeats, and more efficient breathing, especially the carnivorous theropods. Evidence from preserved blood vessel structures in Tyrannosaurus rex bones even reveals protein similarities to modern birds, meaning dinosaurs had advanced circulatory systems capable of maintaining stable body temperature. In other words, dinosaurs could breathe fast, run fast, and live actively, not just lie in the sun like lizards today. If you looked inside the skull of Herrerasaurus, you'd find something fascinating. Its brain wasn't large, but its olfactory bulbs were highly developed. Early dinosaurs had an extraordinary sense of smell, detecting prey from very far away. This was the first invisible weapon of the predatory age. Over millions of years, vision, balance, and motor skills also evolved dramatically, especially in hunters like Allosaurus and Velociraptor. They didn't just run fast. They coordinated, they ambushed, they watched. Science calls this primitive intelligence, a trait only a few species possess, and that separated them even further from ordinary reptiles, which act mostly on raw instinct. A groundbreaking discovery in 1996 inches China. On a tiny fossil of Sinosauropteryx, scientists found traces of soft, filament-like feathers covering its body. Dinosaurs with feathers? The idea forced paleontology to rewrite its entire understanding. Since then, countless other fossils revealed the same. Many velociraptors, microraptors, and Anchiornis had real feathers. Some even had functional wings, allowing them to glide or fly low. This means modern birds are the direct descendants of dinosaurs. They did not go extinct entirely. They simply transformed. When you hear birds sing at dawn, that is the distant echo of the Jurassic Age. Dinosaurs, especially theropods, had lungs and air sacs identical to birds. Their breathing functioned in two directions. Air passed through the lungs once while inhaling and once again while exhaling, meaning there was never any stale air. This highly efficient system helped them absorb maximum oxygen, essential in Triassic and Jurassic atmospheres, where oxygen levels were lower than today. That's how they could run, hunt, and roar for hours, a feat no modern reptile can achieve. As their respiratory and circulatory systems improved, dinosaurs began to grow rapidly in size. Herbivores like Plateosaurus reached 10 meters within just a few million years. By the Jurassic, Brachiosaurus stretched over 25 meters and weighed 50 tons, all powered by the biological engine inside their bodies. Paleontologist Stephen Broussat once said, "Dinosaurs weren't giant because they needed to be. They were giant because their bodies let them." When you put the pieces together, upright hips, four-chambered hearts, bidirectional lungs, feathers, intelligence, warm blood, you see clearly. Dinosaurs were never just reptiles. They were a self-contained biological system, a unique chapter of evolution, a creature with the strength of reptiles, the breath of birds, and a structure closer to warm-blooded animals. A perfect fusion nature once created, and it was this that allowed dinosaurs to rule Earth for 160 million years, 800 times longer than the entire history of humankind. Fact 2. Dinosaurs appeared after the greatest extinction event in Earth's history. Imagine you are drifting through space, looking down at Earth, a blue planet. But the moment you're seeing is not today. It is 252 million years ago. And that planet is dying. Everything you know, oceans, forests, creatures, is disappearing. Fire erupts from the Earth's core like millions of nightmares unleashed at once. Gigantic volcanoes in the region that would one day become Siberia erupt for millions of years, pouring billions of tons of toxic gas into the air, turning the sky blood red and boiling the seas. This is the Permian-Triassic extinction event, the greatest catastrophe in the entire history of the planet, where more than 90% of marine life and 70% of land animals vanished forever. No one remembers the sound of the waves. Coral reefs, once vibrant and colorful, are now only pale skeletons. The sea is dead, no oxygen, no life. Meanwhile, on land, trees burn to ash. The air is filled with carbon dioxide and sulfur, turning rain into acid, eating through stone, killing forests, and covering the planet with a suffocating veil of smoke. Earth, once a grand symphony of life, is now only silence, a painful void in biological history. The great beasts of the Permian, like Dimetrodon and Gorgonopsid, are gone forever. Millions of years pass, and the planet seems to stop breathing. After that devastation, the world becomes eerily empty. Yet in the ashes, life refuses to surrender. Small, surviving reptiles with flexible bodies and efficient lungs begin to multiply in rocky crevices where toxic air cannot reach. Imagine this. Beneath a clouded, ashen sky, a tiny reptile crawls from a crack in the stone. It doesn't know it is stepping into a new era, but that fragile step marks the beginning of the planet's rebirth. In the millions of years that follow, the climate slowly stabilizes. The first rains after the apocalypse pour down, cleansing the atmosphere and awakening seeds buried deep within the soil. Ferns, cycads, and ancient conifers rise again. Insects flutter over damp wetlands, carrying pollen, a small but miraculous sign. Earth is alive again. Once the planet calms from its fury, a new group of creatures begins to rise. Archosauria, the ruling reptiles. These are the distant ancestors of crocodiles, pterosaurs, and dinosaurs. They no longer crawl like their ancestors. They stand upright, move fast, and breathe more efficiently than any creature that came before. Because of that, when the environment changed, they didn't just survive. They conquered the emptiness left by others and claimed the planet. If the death of the Permian was the final punctuation mark, then the arrival of dinosaurs was the first letter of a new chapter in life's history. The Triassic period was a bizarre age of evolutionary experiments. During its first 20 million years, the planet became a colossal laboratory where nature tested thousands of different body designs. Some grew armor like steel, Atosaurus. Some ran swift as the wind, Colophysis. Some looked like crocodiles but hunted on land, Postosuchus. Some succeeded, many failed. But among millions of forms, one small branch evolved the perfect combination. Upright stance, strong heart, efficient lungs, a smarter brain. And from that branch, the first dinosaurs were born. Dinosaurs emerged as the natural heirs of a broken world. They were not the product of luck, but of brutal natural selection in a post-extinction environment. The survivors all shared certain traits: lightweight bodies, energy efficient, good temperature regulation, speed to escape harsh climates. Those traits became the key to dinosaur dominance. When Earth revived, they were already prepared. Primitive dinosaurs, Eoraptor, Herrerasaurus, appeared in South America about 231 million years ago, racing across red dust plains and sparse forests. A new era officially began, the age of dinosaurs. Terrifying numbers. Global temperature rose by more than 10 degrees Celsius. 96% of marine life went extinct. 70% of land life disappeared. It took more than 10 million years for life to recover. Geological evidence points to the Siberian Traps supervolcano erupting for over 1 million years, extreme greenhouse gas buildup causing a global heat spike, ocean acidification, making seas uninhabitable, oxygen levels dropping to only 12–14%. In such a world, any creature with efficient lungs had the advantage, and archosaurs, with their two-way breathing system, survived and gave rise to dinosaurs. In the Karoo Basin, South Africa, and Igualasto, Argentina, rock layers reveal a razor-thin boundary between two worlds. One side is the dark rock of the Permian, the other, red Triassic Earth, where the first dinosaur bones lie. That boundary is the line between death and rebirth. It marks the moment everything old collapsed, and new creatures like Herrerasaurus stepped onto the stage. When paleontologists uncovered the earliest fossils, they noticed something astonishing. There was no gap in life. Right above the layer of death was the imprint of resurgence. Earth, though destroyed, never stops. Nature does not distinguish between destruction and renewal. To it, every ending is merely the start of something new. Without the Permian extinction, dinosaurs might never have appeared. And without dinosaurs ruling the earth, birds, and eventually humans might not exist today. In that strange balance, we find an ancient truth. Nature never stops, it only changes form. From ashes, from the final breath of lost species, life finds a new path to continue. Modern genetic studies show some dinosaur traits: hollow bones, powerful circulation, predatory intelligence, originated in the small reptiles that survived the Permian. Within the DNA of today's birds still lie fragments of those ancient genes, a memory the planet never forgot. Every time a bird beats its wings, it is nature remembering the first rulers after destruction. The Permian extinction was not only a tragedy, it was the most powerful proof of life's resilience. Earth once suffocated, burned, fell into hell, yet it revived and became even stronger. If you could stand at the edge of the Triassic, look up at the grey sky, and see the first Eoraptor sprint past, you would understand. It is not just an animal, it is the symbol of life that refuses to bow to extinction. Fact 3. The first dinosaurs. Small but extraordinary. South America, 231 million years ago, the Triassic sun burns bright low, dry casting its heat upon valleys filled with rising mist. In that air, the rustle of shrubs echoes. A slender figure darts through, no taller than your knee, yet its amber bright eyes scan the world around it. It is Eoraptor lunensis, one of the very first dinosaurs ever to exist on Earth. And though it weighs only about 10 kilograms, this tiny creature was the beginning of a dynasty that would last 160 million years. At that time, the planet was still hot, dry, and covered in volcanic ash. The landmasses were joined into the supercontinent, Pangaea, with desert winds sweeping from west to east. Dense forests had not yet formed. Only low fern groves, cycads, and ancient conifers grew between shallow stream beds. The harsh climate meant only small, fast, and agile beings could survive. Eoraptor and its early kin, like Herrerasaurus and Staurikosaurus, lived in that world. A world without the roars of giant dinosaurs, only the faint patter of tiny footsteps on red earth. Eoraptor measured about 1 meter long, half a meter tall, and 9–12 kilograms in weight. So small, you could cradle it in your arms. Yet its body was a wonder of evolution. It had long, flexible hind legs for speed and quick turns. Its long tail provided balance, and its short forearms bore sharp claws for seizing prey. Eoraptor's teeth were a blend of two worlds, some like carnivores sharp, blade-shaped for cutting, some like herbivores is thin, finely serrated for grinding leaves. Paleontologists believe Eoraptor was an omnivore, a perfect survival strategy in a ruthless world. Its bones were hollow and light like a bird's, a trait far ahead of its time, allowing incredible agility. If you stood in a Triassic grove and watched Eoraptor move, you would not see it crawl like a lizard. It walked on two legs, body leaning forward slightly, tail stretched behind, like a natural counterweight. This posture conserved energy, a vital advantage when daytime heat soared above 40 degrees Celsius. While hunting, it relied on keen sight and sharp hearing. Every faint rustle in the grass made its head tilt, amber eyes flashing a reflex of intelligence and caution. Eoraptor was not strong, but it was swift, elusive, and aware of its world. That sensitivity made it the ancestor of an era. Living alongside Eoraptor was Herrerasaurus, a larger cousin, 3-4 meters long, nearly 200 kilograms in weight. Herrerasaurus was one of the earliest true predators of the dinosaur lineage. It ran on two legs, its jaws packed with long, curved teeth like knives, and sharp claws on its hands, capable of tearing prey in a single strike. What set Herrerasaurus apart was its neck and jaw structure, allowing its mouth to open extremely wide, nearly 90 degrees, much like a leopard or crocodile today. It proved that nature had begun testing the blueprint of the perfect hunter, a prototype that millions of years later would become Allosaurus, Tyrannosaurus, Velociraptor. There is no direct evidence of Eoraptor nests, but fossils from the same era show primitive dinosaurs laid small, thin-shelled eggs. They buried them in soil or covered them with leaf litter for warmth. The hatchlings, less than 20 centimeters long, had to survive on their own within weeks of birth. No parental protection. Survival instinct was nature's first lesson. Harshness shaped the strongest generation. Only the swift, clever, and resilient survived, and they became the foundation of everything that followed. With lightweight bodies and agile movement, early dinosaurs quickly spread across Pangaea. They migrated along river valleys, crossed barren lands, and reached what is now North America, Africa, India, and Europe. The unity of the supercontinent eased their expansion. No seas dividing them, no mountains blocking them, only wind, dust, and time. And in each new domain, dinosaurs evolved differently. Some grew tall with long necks to reach leaves, Plateosaurus. Some developed claws and teeth for hunting, Herrerasaurus. Some stayed small and swift to evade danger. Nature began sculpting the world with the hands of dinosaurs. When paleontologists excavated bones in the Ishigualasto Valley, they found Eoraptor fossils nestled in red rock, surrounded by traces of ancient ferns and spores. Radiometric analysis dated them to 231.4 plus or minus 0.3 million years. The bones were scanned by CT, reconstructed in 3D, and when the full model emerged, it became clear the first dinosaurs were not gigantic monsters, but slender, intelligent beings, bodies optimized like precision machines. Professor Paul Sereno, who discovered Eoraptor, said, "When you look at that skeleton, you understand that evolution does not create greatness from strength, but from adaptation." Eoraptor and Herrerasaurus existed for less than 10 million years, a fleeting moment in cosmic time. Yet in that brief span, they defined the body plan for all dinosaurs to come. An upright stance, strong, balanced hind legs, a long tail for stability, lightweight bone structure, efficient heart and lungs. These traits helped dinosaurs conquer every environment, from the Triassic deserts to Jurassic rainforests to the coastal plains of the Cretaceous. A body born of survival and enduring through adaptation. Eoraptor was tiny, but that tininess was the key. In nature, size does not dictate power, adaptability does. With its light frame, it ran faster, hid better, and lived where larger beasts could not. As the climate shifted, small dinosaurs like Eoraptor adapted more easily, and its humble branch became the root of giants. From Eoraptor, nature shaped Coelophysis, then Dilophosaurus, and eventually Tyrannosaurus rex. Every titan began as a little survivor who refused to disappear. If you sit at night and imagine a Triassic sunrise, red light spreading over hills, heat rising from the soil, you might see a small Eoraptor standing silent. It does not know its kind will rule Earth for 160 million years. It knows only to survive, to feed, to keep walking. Yet that simple truth, that instinct, became the source of future grandeur. Every empire begins with a single step, and in the history of life, the first tiny footsteps of that little dinosaur were the soft notes that opened Earth's greatest symphony. Fact 4. All continents were once connected. The world of Pangaea. Around 250 million years ago, before dinosaurs appeared, the tectonic plates of the planet were still fused into a single mass. Today, scientists confirm this through geological and fossil evidence. Rock layers of the same age and composition, stretching from Brazil to West Africa. Fossils of the same plant species discovered in South America, South Africa, and India. These are traces of a once unbroken world. Pangaea was shaped like a giant letter C, with the Tethys Sea in the middle, a primordial ocean where ancient fish and sea creatures lived. And around it, along the coasts of that massive supercontinent, life on land was gradually establishing its dominance. The climate of Pangaea was harsh to the extreme. Because of its enormous size, the central regions received almost no rainfall, turning into scorching deserts where sand stretched like an endless sea. By day, temperatures could exceed 45 degrees Celsius, and by night, the drop was so drastic that frost formed on stone surfaces. Only areas near the coast had milder weather. There, forests of cycads, ferns, and ancient conifers grew, becoming the first homes of creatures that would later evolve into dinosaurs. Picture this. Across a land that stretched from what is now Brazil to Central Africa, winds carried salty moisture from the Tethys Sea, and among patches of sparse forest, small creatures like Eoraptor ran across the red earth. This was the earliest age of dinosaurs. What made Pangaea remarkable was that it allowed life to move across the entire planet. No seas to divide, no mountain ranges to block the way. A dinosaur species, born in what is now Argentina, could migrate through Africa, into India, and reach ancient Asia, all simply by walking. Because of this wide connection, the earliest dinosaurs spread around the world within just a few million years. Fossils of the same dinosaur genus, such as Plateosaurus, have been found in both Europe and South America, testimony to their cross-continental journey. Pangaea was like a colossal highway of evolution, where life traveled, met, and transformed. But nothing is forever. Beneath the ground, Earth is always moving. Tectonic plates silently shift a few centimeters per year, so slowly that no human can notice. Yet over time, those centimeters become thousands of kilometers. Around 200 million years ago, Pangaea began to split apart. The first fissures opened where the Atlantic Ocean is now, as glowing magma surged from below, forming undersea mountain chains. The Tethys Sea widened, dividing the landmass into two. Laurasia in the north, North America, Europe, Asia. Gondwana in the south, South America, Africa, India, Australia, Antarctica. It was the first symphony of separation on our planet. As Pangaea broke apart, its climate shifted with it. Regions once desert began receiving rainfall, forests returned, and dinosaurs began to migrate. Herbivores, such as Plateosaurus and Massospondylus, moved south in search of new vegetation, while carnivores like Herrerasaurus and Coelophysis followed behind, forming the earliest ancient food chains. The breakup of Pangaea unintentionally triggered massive biodiversity. Each separated continent became its own evolution laboratory, where species adapted in unique ways. In the north, Allosaurus rose to power. In the south, Carnotaurus emerged. And tens of millions of years later, when continents had drifted far apart, these different lineages would evolve into icons like Tyrannosaurus rex, Spinosaurus, and Argentinosaurus. From the deserts of Morocco to the lands of Argentina, paleontologists discovered fossils of the same ancient plants, like Glossopteris, a woody fern with long blade-shaped leaves. This proves that these forests were once connected, and dinosaurs could walk from South America to South Africa over vast land bridges. Findings in Greenland and South Africa reveal layers of sediment containing volcanic ash of the same age, meaning when a volcano erupted in Africa, its ash could fall all the way to South America. Perfect evidence of a continuous Earth. As Pangaea fractured, new seas formed, water evaporated, rain returned, rivers flowed, and life flourished. Before this, only small animals survived the scorching deserts. But now, the climate softened, and the first gigantic dinosaurs like Apatosaurus and Brachiosaurus began to appear. In other words, the breakup of Pangaea opened the golden age of dinosaurs. What looked like destruction was actually nature's gift to evolution. In 1912, German geologist Alfred Wegener proposed the theory of continental drift. He argued that continents were once joined and later split apart. At the time, scientists mocked him, but more than half a century later, evidence from the ocean floor, ancient magnetism, and tectonic motion proved him right. Today, satellites measure that Europe and North America are still drifting apart at 2-3 centimeters per year. India is colliding with Asia, forming the Himalayas. The Red Sea is widening, just as the Atlantic once did, meaning Earth is still moving. And the story of Pangaea is not over. Today, when we see animals on different continents that still resemble one another, like African ostriches and Australian emus, or American crocodiles and African crocodiles, these are legacies of Pangaea. Their DNA still holds the memory of a time under one roof. And even ancient plants like cycads and ferns still grow worldwide, like survivors reminding us that Earth was once united as one giant land. Look at a world map. Imagine sliding Africa against South America, India into East Africa, Australia against Antarctica, and you will see Pangaea reappear, a massive puzzle that time has torn apart. And when you imagine millions of dinosaurs, once walking from what is now Egypt to Brazil, from France to China, you will realize the dinosaur world was not divided, but one single planet, green, warm, and filled with life. Fact 5. Triassic climate. A scorched and desolate world where dinosaurs were born. More than 230 million years ago, this planet was nothing like the one you live on today. There were no green prairies, no winding rivers, only red soil, burning winds, and a sky heavy with ash and dust. This was the Triassic period, the opening era of the age of dinosaurs, where heat and drought did not destroy life, but instead forged it stronger than ever before. When the first dinosaurs appeared, Earth was still recovering from the Permian extinction disaster. Volcanic eruptions had not yet ceased. Vast belts of molten land stretched for thousands of kilometers. Smoke and sulfur blanketed the sky, turning every sunset into a dark red band, like blood and coal. There was no ice at the poles, no ocean as deep as today. The entire planet was one enormous supercontinent, Pangaea, surrounded by a vast ocean, salty and lonely. Winds swept across barren lands, carrying heat and the smell of scorched rock. Earth was not a home for life, but a colossal survival test. At the center of Pangaea, rainfall was almost non-existent for years at a time. The largest deserts in history formed there. Dry winds carried red dust for thousands of kilometers, covering entire plains and dimming the air. Daytime temperatures could reach 50 degrees Celsius, while nights dropped below 10 degrees Celsius. Such extreme variation cracked the ground, prevented forests from growing, and only swift, lightweight organisms with energy-saving bodies could endure. Dinosaurs were born in such circumstances, not in green paradise, but in the inferno of fire and sand. Yet, life still found a path. Along the coastlines of Pangaea, where rain occasionally fell and ancient rivers still flowed, ferns, cycads, and primitive conifers grew in deep green patches. They were the oases of the Triassic. In those rare havens, life began to thrive. Ancient amphibians hiding in small ponds. The herbivorous reptile Plateosaurus wandering through low forests, and Eoraptor, a tiny dinosaur, sprinting through shadows to hunt insects and lizards. The harsh climate imposed brutal natural selection. Only species with light bodies, efficient respiration, and extreme adaptability survived. Those creatures were the true ancestors of dinosaurs. Gigantic volcanoes spewed CO2 and sulfur, filling the atmosphere with sulfuric acid. When rain fell, it became acid rain, scarring the soil, killing forests, leaving the ground bare. But paradoxically, those toxic rains carried minerals from deep underground to the surface, creating fertile lands along rivers. There, life was reborn. Giant ferns emerged, paving the way for herbivorous dinosaurs to rise. Earth was like a biological forge, where pain and harshness did not kill, but shaped adaptation. If you stood in a Triassic desert, you would hear the long howl of the wind, whipping sand into waves like the sea. There were no birds, no insects buzzing, only the sound of a planet still glowing with heat. At times, the ground would tremble as volcanoes erupted. Ash veiled the sky for weeks, blocking the sun, turning day into night. But when the final rays pierced the ash, they shone onto the red sands. And there, the first dinosaurs stood, breathing deeply through the smoke-filled air. It was the very first breath of the dinosaur age. Scientists have found evidence that the extreme heat and low oxygen of the Triassic drove the development of a two-way airflow breathing system. Similar to modern birds, dinosaurs, especially the theropoda, carnivores, evolved lungs with air sacs and four-chambered hearts, allowing more efficient gas exchange. This helped them run, hunt, and stay active all day long, while other reptiles collapsed in the shade. It was as if Earth's smoke and fire had crafted them a supercharged body. Today, when paleontologists excavate the red Triassic layers, they see oxidized sediments, proof of hot, arid, moisture-starved environments. Among those layers lie bones and fossil footprints, the small strides of Coelophysis, Plateosaurus, Herrerasaurus. These fossils reveal the earliest dinosaurs did not live in lush jungles, but on cracked, thirsty, lifeless lands, still walking tirelessly in search of survival. They did not need paradise, for the Triassic hellfire was where they were born. Around 215 million years ago, volcanism began to calm, rain became more frequent, moisture rose from the ocean, and winds carried clouds inland. Deserts slowly became low forests, giant ferns grew tall like buildings, and dinosaurs began to flourish. Plateosaurus reached 9 meters in length. Eoraptor evolved into Coelophysis, faster, sharper. Herbivores and carnivores diverged into distinct lineages. From desolation, life blossomed. From fire and sand, the dinosaur age officially began. Ancient climate models, paleoclimate, show that the Triassic atmosphere contained up to 6,000 parts per million CO2, 15 times higher than today. This kept global temperatures constantly above 35 degrees Celsius. There was no ice in the polar regions. Earth was a global greenhouse, where summers lasted for years at a time. But because of that, life evolved faster than ever before. Species had to adapt, and dinosaurs, with lightweight bodies, powerful lungs, and rapid circulation, became the undisputed rulers of a burning planet. If life is a flame, then the Triassic was nature's greatest forge. Dinosaurs were not born into gentleness, but into hardship, smoke, and trials. They symbolize the power of adaptation, the ability to rise where nothing should live. And because they were born in suffering, they went on to dominate Earth for hundreds of millions of years. So when you look at a dinosaur fossil, imagine the scorching breath of the Triassic, the dry wind from Pangaea, and the sky blazing with volcanic ash, where in silence and adversity, the first spark of the dinosaur era was ignited. Fact 6. Dinosaur body structure. Secrets hidden in bone and blood. Take a deep breath. Imagine you are standing before a giant dinosaur fossil, a skeleton towering like a monument, each vertebra stacked high, each tooth sharp as a blade. But the true wonder does not lie in that appearance. Their secret, the very thing that let dinosaurs rule Earth for 160 million years, lies deep inside, in the bone, in the blood, and in the breath. When paleontologists first excavated dinosaur bones, they believed the creatures must have weighed hundreds of tons of steel. But as they examined each vertebra, they discovered something strange. The insides were hollow. Dinosaur bones, especially in meat-eaters, theropods, and gigantic, long-necked species, sauropods, had systems of air-filled cavities and chambers, just like modern birds. Those hollow spaces didn't weaken the bones, but instead reduced weight while preserving strength. For example, a single cervical vertebra of Brachiosaurus is over 1 meter long, yet weighs only as much as a cow's femur. Thanks to that, those giants could raise their heads 12 meters high without breaking, collapsing, or falling. Nature designed them like bridges made of bone, every vertebra, every joint, optimized for strength and lightness. Covering that skeletal frame was a massive muscular system, arranged like steel suspension cables on a hanging bridge. In Allosaurus, major muscle groups attached to the hips, thighs, and tail, creating powerful leverage for each stride. When it kicked off with its hind legs, the entire body sprang forward like a released bowstring. One leap, and the prey fell. In plant eaters such as Diplodocus or Apatosaurus, the tail and neck worked in opposite motion, balancing a nearly 30-meter body with only muscle and tendon. When you look at a giant fossil in a museum, imagine every muscle flexing, every bone joint in motion, the entire body a colossal machine operating in perfect control. Dinosaurs were not only strong, they were among the most sophisticated biomechanical constructions nature ever engineered. How could a 50-ton animal pump blood up a neck 12 meters tall? That question puzzled scientists through the 20th century. Today we know the hearts of giant dinosaurs must have been 4-chambered, like birds and mammals, unlike the 3-chambered hearts of reptiles. Such a heart could weigh nearly 400 kilograms, beating slowly yet powerfully, pushing blood through meters-long arteries into the brain. Small predators like Velociraptor or Deinonychus had smaller hearts, but much faster beats, high heart rates for rapid oxygen flow, perfect for relentless hunting. This means dinosaurs could not have been cold-blooded, for if they were, they could not sustain the energy needs of such massive bodies. Dinosaurs were thermodynamic creatures. Their blood carried the heat of the earth, beating strong like the pulse of the planet. When researchers CT scanned fossils of Majungasaurus and Tyrannosaurus rex, they found pneumatic openings within the ribs and spine, air spaces once filled with air sacs. This is proof dinosaurs had a two-way respiratory system. Air passed through the lungs once on inhalation, and again on exhalation. No dead air like in humans or reptiles. Every breath was fully used. Thus, they survived the low oxygen atmosphere of the Triassic and Jurassic, still hunting, running, and growing faster than any other animals. That was their greatest secret, a perfectly linked circulatory respiratory system, turning their bodies into the highest efficiency biological engines on the planet. For decades, scientists debated, were dinosaurs warm-blooded or cold-blooded? Today, the answer is becoming clear. They were neither entirely one nor the other. Dinosaurs had high metabolic rates, yet conserved energy like reptiles. In other words, they maintained stable body temperatures thanks to their massive size, but did not need constant feeding like warm-blooded animals. Blood cell fossils in T. rex bones show proteins and red blood cells with bird-like structure, meaning highly efficient oxygen transport. This semi-warm-blooded nature helped them survive both burning heat and freezing cold. From Triassic deserts to Jurassic rainforests, a flexible, adaptable physiology. That is what made them Earth's ultimate rulers. Look at a slice of dinosaur bone under a microscope, and you'll see growth rings, like age rings in tree trunks. Each ring marks a year of life, revealing how fast they grew and how harsh their world once was. In Apatosaurus, the thick rings reveal rapid growth, from birth to 30 tons in just 20 years, a growth rate unmatched by any reptile. This shows an extremely powerful metabolism, a sign of continuous biological activity, of a creature built for constant motion. Dinosaurs were not only strong inside, their skin was a natural shield. Species like Ankylosaurus or Sauropelta developed bony armor plates called osteoderms, small bones beneath the skin, connected to muscle, providing both protection and heat regulation. Others bore primitive feathers, like Sinosauropteryx or Microraptor. Feathers not only for warmth, but also for thermal control, sensing airflow and guiding movement. Thus, the dinosaur body was a multi-layer defense system, strong within, armored outside. The brains of dinosaurs were small for their size, yet their structures were remarkable. In predators like Allosaurus or Velociraptor, visual and balance regions were highly developed. They had raptor-like binocular vision and could twist and turn with incredible speed during a chase. In plant eaters, though brains were smaller, they had an auxiliary nerve center in the hips and tail, controlling rapid reflexes. In other words, the body reacted before the brain even noticed. Nature made dinosaurs creatures of instinctive perfection. Whenever you see a bird take flight, know that you are seeing a living dinosaur. Everything from hollow bones, four-chambered hearts, air sac lungs, feathers to locomotion design, all are direct inheritances from dinosaurs. From Archaeopteryx at the end of the Jurassic to the sparrows of today, there is a single evolutionary thread spanning hundreds of millions of years, a thread beginning from the scorching breath of the Triassic. The structure of dinosaurs was not just biology, but a reflection of the planet itself. Bone, formed from minerals in the earth. Blood, from ancient seawater long evaporated. Breath, from a sky filled with volcanic ash. They carried within them the DNA of the earth, and thus, with every breath a dinosaur took, the planet itself seemed to breathe. Imagine it. In the ancient night, a colossal Brachiosaurus, lifting its head high, drawing in a deep breath, lungs expanding, and the whole world seems to inhale with it. Slow, heavy, eternal. Fact 7. The first giant dinosaurs when nature learned how to build living towers. After the arid period of the Triassic, Earth gradually became wetter, forests returned, rivers overflowed, and that was when evolution changed its strategy. Previously, dinosaurs like Eoraptor or Herrerasaurus survived thanks to speed, agility, and small size. But when the environment became safe and abundant, size started to become an advantage. The first herbivores began to grow quickly, to reach leaves high above, to avoid being hunted, and to protect their young. Nature began experimenting with weight, height, and endurance. The result, the largest creatures Earth would ever see, Sauropodomorpha. Around 214 million years ago, in the land that is now Europe, a new species emerged, Plateosaurus engelhardti. It was nearly 10 meters long, weighing over 4 tons. A mobile mass of muscle with a long neck, a balancing tail, and flat teeth made for grinding leaves. Unlike its smaller ancestors, Plateosaurus walked on all fours, but could stand upright when reaching for high leaves. The structure of its hips and thighs allowed it to lift itself like a pillar. Every heavy but steady step marked the first tremor of the colossal age to come. Fossils suggest Plateosaurus lived in small herds, traveling near rivers, feeding on young leaves at dawn, moving slowly through fern forests. It was the perfect draft for the true giants that would follow. The descendants of Plateosaurus developed longer necks, smaller heads, lighter bodies. By doing so, they could feed at heights unreachable to others. About 200 million years ago, Anchisaurus appeared, a transition between smaller dinosaurs and giants. It was 7 meters long, yet light and slender, with hollow bones, a long neck to reach high, a long tail for balance, and a strong heart pumping blood upward. That was when Earth learned how to build living towers. The long neck was the upper floors, massive legs were the pillars, hollow bones the steel frame, and a powerful circulatory system the engine driving energy. Every new species perfected another detail, and millions of years later, that tower would be called Brachiosaurus. As bodies grew larger, the first challenge was weight. A creature weighing 40 tons must fight gravity itself. But nature had the answers. Hollow bones to reduce mass, a biomechanical balance between neck and tail, a highly efficient heart-lung system, and especially, 4-legged movement stable as pillars. Thanks to that, Brachiosaurus, Apatosaurus, Diplodocus could reach lengths of 25-30 meters, weighing tens of tons, yet walk slowly and smoothly without collapsing. Nature, by refining every tiny detail, turned such creatures into masterpieces of biological engineering. These giants had to eat constantly. It is estimated that Brachiosaurus consumed up to 400 kilograms of leaves per day, but they didn't chew much. Small jaws, chisel-shaped teeth, they simply cut and swallowed. Digestion was powered by microbes in massive stomachs, similar to cows today. The process was slow but continuous, feeding them a steady stream of energy to maintain their size. So imagine, in the Jurassic forests, everywhere the sound of leaves being cropped, deep, rumbling bellies, and breathing heavy as the pulse of the earth itself. Every breath a measurement of vitality. To pump blood up to a head 10-12 meters high, these animals needed gigantic hearts and a network of blood vessels thick as roots. Studies of Brachiosaurus suggest its heart may have weighed more than 400 kilograms, with pressure 3 times greater than a human heart. A system of air sacs along the spine, stored air and reduced weight. Every breath moved air in a continuous loop, like a natural turbine engine. Thus, despite their height and mass, they breathed as lightly as the wind. Many imagine giant dinosaurs moved like turtles, but fossil footprints tell a different story. In Colorado, USA, scientists discovered Apatosaurus trackways, parallel, rhythmic steps spaced exactly 2.5 meters apart, indicating speeds of 5-8 kilometers per hour. Very steady, sustainable for hours. When moving, herds of giants created minor earthquakes, sounds that thundered across the land like the Earth's heartbeat. They did not need to run, because every step they took was already absolute power. The brain of Brachiosaurus was only the size of an orange. Small for such a body, but enough for sensory and motor control. More importantly, auxiliary neural clusters in the hips and tail allowed rapid reflexes, a second brain controlling the lower half. So when attacked, the tail could lash like a steel whip in an instant without waiting for orders from the head. A massive creature, yet fast and accurate in reaction. Proof of nature's mechanical intelligence. Evidence suggests Apatosaurus could produce deep calls through its long trachea, sound resonating across kilometers, like a horn echoing through the woods. These calls help them communicate, signal movement, attract mates, or warn of danger. Imagine a Jurassic dawn, mist still thick, and somewhere in the valley, a low, booming call rolls out. Slow, deep, lingering among ancient mountains. That is the voice of a giant, of the majestic life we now only hear through stone. From the small Eoraptor of the Triassic to the mighty Brachiosaurus of the Jurassic, it took only about 30 million years. A brief moment in planetary history, but in that moment, nature performed a miracle, turning small, swift animals into the tallest living towers ever to walk Earth. No steel, no concrete, only bone, blood, and time. And as the sun set on the ancient forests, those colossal silhouettes moved slowly through the red-gold light, like breathing temples, magnificent witnesses of evolution. If there was ever a moment when Earth reached perfect grandeur, it was when Brachiosaurus lifted its head to the sun, and its breath became the breath of the planet. Fact 8. The first predators. When Earth learned to create fear, the earliest dinosaurs, like Eoraptor or Herrerasaurus, were not just creatures that survived the harsh dryness. They were the result of ruthless selection. Run faster, see farther, strike before being struck. Nature did not only create herbivores to feed, but also predators, beings capable of calculating, ambushing, and killing. It was a major turning point in Earth's history. For the first time, this planet had a concept of hunter. Around 231 million years ago, in the lands that are now Argentina, a new species appeared, Herrerasaurus ishigualastensis. It was 3 meters long, nearly 1 meter tall, weighing around 200 kilograms, small enough to be agile, yet strong enough to kill. Its hind legs were long, its hands armed with sickle-shaped claws, and its jaws lined with serrated, knife-like teeth. Its jaw joint had a special structure. It could slide slightly when biting, like a shark's mechanism. This allowed it to tear flesh into pieces with a single snap. When it walked, Herrerasaurus leaned slightly forward, its tail held out for balance, its eyes facing forward, binocular vision, perfect for estimating distance when it lunged. That was the brain of a true hunter. The muscles of Herrerasaurus were built for speed. Large thigh muscles, long tendons, helped it spring like a cheetah. When it charged, all of its power focused into a single bite. Its top speed estimated at up to 40 kilometers per hour. Its forelimbs were short, but extremely strong, each finger tipped with claws up to nearly 15 centimeters long. One swipe could tear the neck of smaller prey apart. And when it bit, the jaws locked tight, the serrated teeth sunk deep and pulled backward. A lock and rip mechanism that millions of years later, Tyrannosaurus rex would inherit. After Herrerasaurus, nature created another type of hunter, faster, smaller, and more dangerous. That was Coelophysis, a small carnivorous dinosaur, 2.5 meters long, living around 210 million years ago in North America. Slender body, hollow bones, great speed. Coelophysis was the master of agility. It did not rely on strength, but on intelligence and reflexes. Studies of its skull show it had extremely sharp low-light vision, allowing it to hunt at dawn or dusk. Coelophysis hunted in packs. Fossils in New Mexico show dozens dying together, proving they lived and moved as a group. Imagine a misty Triassic night. In the darkness, dozens of golden eyes move silently. And then, in a single heartbeat, they strike as one. It was the first moment in history where Earth witnessed organized hunting. The first predatory dinosaurs had larger brains than herbivores of the same era. Their visual and balance centers were well developed. Nervous pathways stretched from neck to hips, triggering instant reaction to any motion. When prey flinched to flee, Herrerasaurus had already leapt before thought could register. It was not intelligence, but pure instinct, sharpened by millions of years of survival. Every leap, every bite was the culmination of evolution, condensed into one moment. Nature did not create predators to slaughter, but to keep life running. When herbivorous dinosaurs multiplied, another force emerged to balance them: the hunter, removing the weak, keeping ecosystems healthy. And so, death became part of the rhythm of life. In the world of dinosaurs, life and death were not opposites, but companions. At Ghost Ranch, New Mexico, archaeologists discovered over 100 Coelophysis fossils, stacked together in the same red rock layer. Several individuals contained small bones inside their stomachs, possibly from their own kind. This led to a heated scientific debate. Did Coelophysis practice cannibalism? The answer may be yes. When starving, they hunted even their own. A brutal yet logical survival behavior. In nature, there is no guilt, only the need to survive. Most early carnivorous dinosaurs had forward-facing eyes. This created stereoscopic vision, allowing precise distance judgment to strike prey. Meanwhile, herbivores had eyes on the sides for a wider view. This difference split the world in two: those who look forward to kill, and those who look around to survive. It is one of the oldest divisions of life, and it still exists in nature today. As predators evolved, their behaviors became more complex. Some learned to ambush, some chased in groups, some attacked when prey was most vulnerable at water. When injured, in the dark, it was no longer just reflex, but strategy. Nature was slowly approaching the idea of thinking. What Herrerasaurus and Coelophysis achieved became the foundation for every predator that followed. From Allosaurus, Velociraptor, to Tyrannosaurus rex. Imagine a Triassic sunset. Gold-red light spreading across the forest. The air still, only the sound of wind. And then, in that moment, a roar breaks out. Short, sharp, cold as a blade cutting air. From behind the brush, Herrerasaurus lunges, its eyes locked onto its prey. One leap, one bite, one breath, and silence returns. Not cruelty, not malice. It is simply the circle of life. Fact 9. Herbivorous dinosaurs, gentle giants who kept the planet alive. Not all creatures were born to fight. While Herrerasaurus and Coelophysis sharpened teeth and hunted, on the other side of the forest, another group of dinosaurs evolved in the opposite direction. Big, slow, and peaceful. Instead of claws and fangs, they had long necks, flat teeth, and enormous stomachs. They did not need to kill to survive, only to eat and keep the food chain in balance. That was when the planet began forming a new rhythm, a pace slow, steady, and deep like the drumbeat of time. Around 214 million years ago, in ancient Europe, where fern forests covered the valleys, appeared the first large-scale herbivorous dinosaur, Plateosaurus. About 9 meters long and 4 tons in weight, it was one of the earliest giant plant eaters. Its long neck let it reach leaves. Its spoon-shaped teeth crushed tender foliage, and its thick tail kept its balance. Fossils reveal Plateosaurus lived in herds, moving together, resting together, protecting their young within the group. In the violent world of the Triassic, they survived through unity and patience. No weapons, no speed, just calm endurance. To sustain a massive body, herbivorous dinosaurs had to feed almost all day long. Diplodocus, Apatosaurus, Brachiosaurus, monuments of the Jurassic, could consume 300-500 kilograms of leaves per day. They did not chew thoroughly. Teeth simply cut, and leaves were swallowed straight into a giant fermentation stomach, where microorganisms broke down cellulose. Their bodies were slow-moving digestive factories, quiet yet efficient, a colossal energy cycle running in silence, nourishing forests and even the atmosphere. For when they fed, they also spread seeds, fertilized soils with their waste, and prevented plants from growing too dense. Nature used herbivorous dinosaurs to regulate itself. In Brachiosaurus, the neck could reach 12 meters, as tall as a 4-story building. Its vertebrae were light with air cavities, each like a biological steel beam. When it raised its neck, the entire world seemed to bow beneath it. A small head, large eyes, watching quietly through the canopy. No weapons, only majestic composure. The warm and humid Jurassic climate made forests thrive, and the long-necked dinosaurs became the gardeners of the planet. They fed high above, leaving space for young plants to grow below. Every stretch of the neck, every leaf clipped, was an unconscious act that helped the forest breathe. An adult Apatosaurus weighed 30-40 tons, yet it rarely fought. If attacked, it would not run or roar, just turn and whip its tail. That swing could break a predator's bones, but most of the time, it didn't need to. Its sheer presence was deterrence enough. Nature granted them enormous size, not to dominate, but to defend peace. In the ancient world, power did not belong only to attackers, but also to those who stood still. Herbivorous dinosaurs seldom lived alone. They traveled in herds, long lines stretching across valleys. In Utah, USA, archaeologists found fossils of an entire Diplodocus herd, over 20 individuals killed at once in an ancient flood, from young ones the size of horses to adults as tall as 3-story houses. This was no coincidence. They lived, fed, moved, and died together. The herd was home, protection, and memory. In the ancient night, while predators lurked in the woods, the giant plant eaters stood close, eyes on one another, a circle of trust and survival. Herbivorous dinosaurs did not merely eat leaves. They regulated the planet's entire plant cycle. When they overbrowsed one area, they moved on, giving the vegetation time to recover. They unintentionally spread seeds through their dung, replanting forests far from where they fed. Without them, forests would grow too thick, blocking sunlight, and smaller species would disappear. Thanks to the herbivores, forests had a breathing rhythm, inhaling as they grew, exhaling as they were grazed, a perfect cycle nature maintained for millions of years. When drought came, waters shrank, leaves withered, many collapsed upon the plains. But even in death, they became the source of life for countless others. Flesh fed scavengers, bones sheltered insects and sprouting plants, minerals returned to the soil, feeding the next generation. Their death was not an end, but the beginning of a new cycle. The entire life of a herbivorous dinosaur was a cycle of giving, eating, breathing, migrating, dying, and continuing to nourish the planet. At a Jurassic dawn, dozens of Diplodocus stood in the mist, their breath drifting as white clouds, forming a gentle, steady chorus of air. No thunderous sound, only leaves falling, breaths blending into the wind. It was the sound of peace, the sound of a planet living slowly. No war, no chase, just steady, humble, quiet existence. When we look at an Apatosaurus fossil, we see not only stone and bone, but a memory of patience. Herbivorous dinosaurs were not great because of their strength, but because they lived in balance with the world around them. They did not need to conquer, they only needed to exist, and that existence nourished the entire planet. In the silence of the plant eaters, Earth found its true heartbeat, slow, steady, and full of gratitude. Fact 10. When giants learned to defend themselves, defensive weapons and survival strategies of herbivorous dinosaurs. At first, herbivorous dinosaurs relied only on their size to defend themselves. A 5-meter tall, 20-ton diplodocus only had to stand still to make predators hesitate. But predators evolved too, faster, smarter, and hunting in coordinated groups. Nature was forced to create new defensive strategies. That was when biological weapons appeared, from sharp spikes to steel-like tails, to thick bony armor, and even united herd strategies. Around 155 million years ago, a strange creature emerged on the North American plains, Stegosaurus armatus. It was 9 meters long, 5 tons in weight, but what stood out most were the 2 rows of plate-like bones along its back, and a tail armed with 4 sharp spikes nearly a meter long. At first, scientists believed the plates were for protection, but in fact, they contained complex blood vessels that helped regulate temperature and could even flush bright red when provoked. A visual signal to warn enemies, and the spiked tail called a thagomizer was one of the most effective weapons of the Jurassic. A single tail swing from Stegosaurus could break bones or puncture a predator's belly. When you see that tail fossil in a museum, imagine the sharp whistle of air as it sliced through. A gust of survival. In the late Cretaceous, when predators like Tyrannosaurus rex ruled the land, nature answered with a creature no less formidable, Ankylosaurus magniventris. It was 7 meters long, 8 tons heavy, its entire body clad in bony armor up to 5 centimeters thick, each plate linked like a shield of living metal. Its head was flat and hard, with low-set eyes, and at the end of its tail, a massive, hammer-like, bony club. This was the first biological tank in history. When attacked, Ankylosaurus did not flee. It lowered its head, raised its armor, and spun fast. A single tail strike could shatter a T-Rex's leg. Studies of fossils show cracks on predator bones, matching the impact force of an Ankylosaurus tail, proving that the battle between offense and defense had reached the highest tactical level. If Ankylosaurus was a tank, then Triceratops was a knight in armor. Living at the end of the Cretaceous, about 68 million years ago, it stretched 9 meters long, weighed 12 tons, and its head bore 3 great horns, 2 above the eyes nearly 1 meter long, and a shorter nasal horn. Behind its head was a broad frill, protecting the neck, but Triceratops did not use its horns only for battle. Recent studies suggest its horns and frill were also tools for communication within the herd, to recognize one another, to display strength, and during mating season, to choose partners. Yet, when cornered, it could become the most terrifying enemy of T-Rex. Fossils preserve bite marks on Triceratops skulls that match T-Rex teeth, and sometimes the reverse, a T-Rex killed by horns driven through its chest. No spikes, no horns, yet long-necked dinosaurs had their own weapon, weight, and unity. An adult Apatosaurus weighed 30-40 tons, and a single turn of its body could make the earth shake. When attacked, the herd formed a circle, young in the middle, adults on the outside, tails whipping outward like a living fence. This same strategy is still used by African elephants today, proof that collective defense instincts are hundreds of millions of years old. In the world of herbivorous dinosaurs, weapons were not only for striking, but for saying, "Don't come any closer." Armor colors, frill shapes, horn heights, all were visual languages of the ancient forest. Plates flushed red as blood surged. Horns rose when males faced rivals, and when sunset touched their skin, the entire forest seemed to blaze in an evolutionary symphony of defense. Not every species chose brute strength. Some herbivores chose wisdom. Iguanodon, from the early Cretaceous, developed a thumb spike, a small but effective weapon used only when necessary. They lived in large herds, warned each other with calls, and ran upwind to avoid the scent of predators. Life learned strategy, and gentleness learned to defend itself. One herbivorous dinosaur could be killed, but a whole herd could not. Research in Montana shows fossil traces of Maiasaura, the good mother lizard, clustered into large nesting grounds with hundreds of eggs at the same developmental stage. This means they laid their eggs together, raised and protected their young as a community, a society, a system, and within it, safety born from cooperation. Nothing is more frightening than the silence of a giant. A Brachiosaurus did not need to fight because predators knew they could not win. When Allosaurus or Ceratosaurus charged, it only had to lower its head and place a foot weighing tons upon the ground, a seismic warning of dominance. No blood needed, only the weight of existence. Sometimes, the greatest power is not in action, but in the ability to stop others from acting. From Stegosaurus to Ankylosaurus, from Triceratops to Brachiosaurus, every herbivore tells the same story. That defense is not fear, but the will to continue living. Nature taught not only how to fight, but how to stand firm, slow, and enduring.